Alright, so these are the answers to the next example up here. What did I do? It says that ZY is a midsegment, which means it's parallel to this line. And it's also splitting this line into two equal parts. I'm sorry, splitting this side into two equal parts. And it also says that XZ is a midsegment, which means that it's splitting this line into two equal parts. And it also means that these two lines are parallel and these two lines are parallel. And then it says find each measure. So I went and found all the measures I could. We got XZ is equal to 1/2 of RT. And we're given RT is 13, so we plug in. And we can find that XZ is 6.5. And then we have XY is equal to 1/2 of ST. But we're given XY is 7, so I plug in 7, and I found that ST is 14. And I think that's all that we can find given the information we have. So I'm going to go ahead and move on to the next section. And that's up here. We have congruent parts of parallel lines. If 3 or more parallel lines cut off congruent segments on one transversal, then they cut off congruent segments on every transversal. So in this image here, we have 3 parallel lines cut off by this transversal here. And you could see that these two segments are congruent. So that means that any transversal that cuts these 3 parallel lines is cut into congruent segments. So that means that this segment is congruent with that segment there. And if I had another transversal here, it would also be cut into congruent segments, right? So let's go ahead and try to solve a problem using that information. It's right here. We have 3 parallel lines. They're cut by 2 transversals. But we're given that this transversal is cut into 2 congruent parts. Now, because of the congruent parts of parallel lines, corollary, we can also say that any transversal that cuts these 3 lines is going to be cut into congruent parts. So this side here is going to be congruent to that side there. So we need to find x and find y, and that's going to be easy because we know that they're congruent. So our equation is going to be 6x minus 5 is equal to 4x plus 3. And then we'll solve for x. Right? So we'll subtract 4 from both sides. We'll get 2x. We'll add 5 from both sides. We'll get 8. And then divide by 2. We get x is equal to 4. And then our second equation is going to be here to find y. So that's going to be 3y plus 8 is equal to 5y minus 7. So I'll subtract 3y from both sides. I get 2y. I'll add 7, and I'll get 15. Divide by 2, and I'll get y is equal to 7.5. And I found my x and found my y. And then here we have another example of this corollary. This corollary says that proportional parts of parallel lines, if 3 or more parallel lines intersect 2 transversals, like we have here, we got 3 parallel lines intersecting 2 transversals, then they cut the transversals proportionally, which means AB over BC is equal to EF over FG, right? So we get this proportion that we can create an equation from. So let's go ahead and look at this example here. We have these 3 parallel lines, right? And so what does that mean? That means we can create a proportion. We could say that this segment over the length of this segment is equal to this segment over the length of that segment. So let's go ahead and do that. We'll do 7x minus 2 over 4x plus 3 is equal to 8 over 8. And then how do we solve for x? Well, we've got to cross multiply. So we get 8 parentheses 7x minus 2 is equal to 8 parentheses 4x plus 3. And then, yeah, we got to solve this guy. So it's going to be 56x minus 16 is equal to 32x plus 24. Right? Then we'll add and subtract on both sides. And so on this side, we'll get 24. X is equal to 30 is 40. Yeah, that sounds right. Because we're adding 16 to both sides. We'll divide by 24, and we'll get x is equal to 1. And then there's going to be a fraction in here. So let's go ahead and drop it in. Let's say 40 divided by 24, 1.66. And then let's use it again for this problem here. We have three. Do we have three parallel lines? No, it doesn't look like we have three parallel lines. It doesn't even look like we have parallel. Oh, yes, we do. Because they give us that we have a right angle here and a right angle there. And yeah, there was a theorem. I don't know the name of it off the top of my head. That says that if two lines form right angles on the same line, then those two lines are parallel. So we know that this line here is parallel to that line there. So knowing that they're parallel, what can we say? We can say that since these two segments are congruent, that these two segments here must also be congruent. Right, that sounds good to me. So we'll do 2x plus 1 is equal to 3x minus 5. And let me put my congruency signs there. I'm going to subtract 2x from both sides and add 5. So I get x is equal to 6. And we are done. Right? And so, yep, you're going to be using these two corollaries to solve these problems down here, right? And again, as a review, what do they say? They say that if you have three parallel lines cut by a transversal, then and one of the transversals is cut into congruent segments, then that means any line is going to be cut. Any transversal is going to be cut into congruent segments. Okay. And yeah, that's what is said over here, is that we can create a proportion, right, where that line over that line is equal to that line over that line, right, if we have three parallel lines. So, yep, so we'll go ahead and use that information to solve these exercises down at the bottom.